Okay, so this video is technically the second hint to the brick wall Gaia challenge that we're doing there on the Facebook group. But I figured in this part of the process, we could actually talk about something that's useful across the board. It's not just for that specific challenge. This is something that I utilize on some techniques, actually, that I also utilize in order to not just find edges, which is what we're going to talk a bit about here, but also some of these base core techniques are used to eliminate all sorts of things or enhance specific things. The idea is isolating data that you want to use one way or another. So in this particular case, we're going to focus on selecting edges, and they can be interior edges, so things like creases, which you can see here, and then exterior edges, which are the things that sort of stick out, so things that you could rub your hand kind of against. So sometimes you want only exterior edges, sometimes you want interior edges, sometimes you only want vertical edges. So these different methods tend to isolate these specific things depending on how they're being used. So let's take a look at some of them. I've got this basic shape here, and we're going to come in and we're going to do a blur, and then after the blur we're going to do a difference. So this is a core technique. You do something to change the surface, and then you come back in, set it to 100% and set it to difference, and then that will isolate that specific information. Now I've done also an auto levels and made this into a mask by pressing T so that you can see that it renders as a mask. And then using height, I can use that to eliminate or enhance specific things. So if I, reduce the min range here, I can get rid of like the vertical lines, whereas I get to keep the ridge information on the top and the bottom. And of course, how thick the lines are and how much detail is picked up is based on the method of blur that you use. Currently, there is an issue in the version that I'm using. I should probably download the update. But in my particular case, I can only use fast and smooth because Gaussian, radial, and motion are changing the height information. So depending on the method that you use and then how powerful you do it will determine how that changes and what kind of detail is picked up. So high frequency, mid frequency, and so on and so forth, and you can isolate that detail. So this is a method I use quite a lot for a lot of different things. Another method is aperture up and aperture down. So you take a surface and you can contract or expand it. And then go in the opposite direction. So I contracted, then expanded, which basically brings it back to how it was, except that high frequency detail will be gone in this case. I use this for a variety of different purposes. You notice that it's basically put sort of like a bevel on a lot of these things. It's not the same as blurring it. Blurring a surface, of course, is going to have like an overall sort of roundness. So if we try and pick out the differences here, right here, you can kind of see it. And then when we do that, it's done something a bit different. And here, it's picking up vertical lines much more consistently than it is those horizontal lines. And if we go ahead and clamp that down, this is what we see. We've got just the vertical line information. I could play with this a little bit more. See if I can get into those lower ranges. There we go. Let's get it down here. See if we can enhance that. bit stronger. This is kind of neat. It's picking up sort of like details that feel more like a structure. Would be like a happy accident. So again, I can use this to isolate just the vertical lines and ignore the horizontal. So that could be useful in certain cases. Let's go with surface text. And so this is used, it's got a few different settings in here to do different things. Trace is the one that comes in and traces lines. And it does exterior edges and interior edges, and it gives them different values. And so as a result, we could use this information to isolate interior edges or exterior edges that we wanted. Now, it doesn't eliminate the verticals, but we could combine it with this other method to then try and eliminate those. So again, it's a game of playing, what is the information that I need? How can I get it? And then if it doesn't provide all the solution, well, what is another way of then selecting this other thing that I want to try and get rid of? And then you can use that in a subtractive or additive manner as you need. So in this particular case, it's giving me a grayscale mid section. And so if I just input like a grayscale using constant, we can then isolate the two or bring the two together in one set. So I'm getting rid of like the middle information, and I'm converting both lines into positive values, because what the difference does is it says, hey, what is the difference between the two? I'm going to isolate that and show it to you. So rather than having to choose between the high range and the low range, if I just put in a mid value and eliminate the mid value, it leaves me with both the high and the low as, white lines, which are isolated. And then we can try and clamp those down. And my values are a bit off. Probably because my mid value is not clean. It's not the exact right amount. So there we have that, and then I could like that. So we can have those lines together. So just playing with the values a little bit further and we'll get something. Moving on, we have a sharpen. So when we take a sharpen, what does it do? It takes any kind of visible crease and it tries to enhance it a little bit. So when we do that, we notice a lot of difference on the top ridges in there, but it seems to be ignoring interior edges. And if I adjust my clamp, I can also use that to try and eliminate some of the base value. Bring that up. And thin out the vertical lines if I wanted to. There we go. And then something like a small blur and then another clamp or height would get rid of those tiny little bits there and smooth the line. So this method can be good for grabbing exterior edges and things that are already high contrast will be more visible. If we go to our curvature method, which is the common method for going ahead and isolating sort of exterior edges, it has min and max to try and isolate the value of change. You have different methods in here for the averaging. It's got an invert node on automatically, which you could then turn it around and get white lines on black or whatever you want. But ultimately, it's coming in and selecting those, and that's its job. It's meant to do that. I have some additional stuff in here that I'm using for a different purpose, or at least to try and control something else that we'll talk about with a different shape, which is going to be the Voronoi over here that I'm going to plug in right now. Okay, so with the Voronoi here, we have ridges, but there's a little bit more than that. We have ridges, but we have a lot of high frequency detail across the surface, and we have to be careful of that. So if we look at our methods, you can see the blur comes in, and what it tries to isolate is any changes. So with this, adjusting the values, do our best. We can try and eliminate some of this interior frequency detail, but it's going to be difficult because they're always going to be there. Some methods are going to be a little bit more useful than others in this context. And again, if you combine multiple methods, sometimes you can isolate things that you want. So if I want to get rid of these features here, there might be a way to do that by using like an aperture, contract, and then expand, which is going to isolate the thicker areas, which are currently thicker than most of the edges. And then I can use a difference on that to get rid of that and isolate mainly the thin bits, which are mostly the curvature here. So that's that method. Our aperture method, what does it do? It does a pretty decent job on all these ridges. These ridges are actually really quite strong. It does a pretty good job on that. And then we've got vertical lines. So because these are such thin ridges, the aperture method actually does a pretty good job in eliminating them. Anything that is thin data, right, it will extract it by basically getting rid of it. So all these thin ridges are eaten away by using the aperture. Now there's variable thickness here, granted, of course, but it does a decent job at trying to pick that out. Now, not only that, if we look at the lines that are here, they're not going horizontal, they're all pretty much vertical, which could be useful to me because then I'm isolating just stuff that's going in a specific direction. So there's other ways that I could process this further. I could probably do a blur and then a height or a clamp to then isolate what was left over, and it would probably eliminate a bunch of these lines in the middle. So basically doing this process over here added to this process. Let's try the SurfText trace. And do a trace, combine, and then try and isolate. This is what it's given us. Tweak that a little bit. So in here, it looks like it's picking up some of that. Although it's less visible in the viewport at the moment. So it's just a matter of sort of acknowledging that it's there, which is why setting the 2D viewport and setting it to show the raw data can be useful in trying to pick out exactly what it's doing, but it's not getting all the ridges. So this is not a good way of isolating peaks, harsh ridges from this kind of surface. So SurfText is not doing its job there. If we try the Sharpen method, what does the Sharpen method do? The Sharpen method gives us pretty strong information along those ridges, and then weaker information on the high frequency noise. So that's pretty good. So that's done a fairly decent job, and then we can process this data further to try and get something good out of it. And of course, we have our curvature method, and the curvature method is everything. It's gone in and it's grabbed everything. So this is where this extra information is coming in here. So rather than kind of having all of this all over the surface, doing a little bit of an aperture to try and protect the line. So because it's inverted, I've done a contract, and the contract has made the dark values thicker. And then if we go ahead and subtract its own surface, which is not what I've connected. Let's fix that. Missed one of the nodes. So I've subtracted its own surface. What it's going to do is it's going to subtract with variable values. So it's going to sort of pull it down just a little bit. So think about like this surface shrinking a tiny bit and then being subtracted from the surface. And then if we go ahead and check that and then aperture the other direction, then we isolate the ridges in these lower regions and we're getting areas of peaks. So interesting, potentially useful, maybe not specifically to isolate just the edges, but it is pretty focused on peaks, right? It's doing a good job at kind of picking those out along with those ridges. So this might be useful in the cases of determining things like snowfall. If I want to control the amount of snowfall in an area, I can use this as a snowfall mask to say snow in these areas, and then I'll get something off of that. Let's see what that looks like. Okay, so I'm going to take this and I'm going to plug it into here and say that's where snow falls. It's mainly those areas. And then we'll play with our scale as usual. Bring that up there. We'll play with our verticality. There we go. Just tweak that to make it a bit more natural than the mask was doing in the first place. And there we have it. Now we're controlling snowfall in that region. We can increase the duration to make that a bit more intense. And we could do other things with that as well. So that's where it's potentially useful. This is something that we could do with that particular mask. So again, each method has their own benefits and disadvantages. Now, areas where you should probably play with it a little bit. I have stuff where I'm dealing with like cells here. And again, some of these methods will isolate vertical lines better. Others will do horizontal lines better. Some are really good at really isolating just all the flat areas that are like steep ridges. And if we use something like a stratify here we have a lot of curvature all over the place. And you can see how these different methods in here will respond to these different kinds of surfaces. And I promise you will get some unique and different results. Some will be very useful in the cases of, while it's not selecting every single edge, it is isolating different regions, which is good because then you can use that to erode only those areas or have snow only fall in those areas or do something else to those regions. So isolating, that kind of information can be useful just to add variety to any kind of surface and break up the excessive regularity ultimately. So just to quickly kind of illustrate some of this, we'll take a look. What does the height method do? It's come in and it's picked out a bunch of different areas. I can change these values, but we're getting like this big steep back wall here. that might need some additional processing, maybe do a mild blur to it and then add detail so that it looks like it has more information, right? It's a really steep ridge. And you look at this and it's really kind of isolated that because there's more of that steep ridge on the side than there is over here. So that becomes a problem area. It's an area that I'm going to have difficulty with making it look right simply because it's just straight up and down lines. So using this blur method, I can use that to try and, isolate really steep ridges that I can do something with, and then ignore other areas that already have, enough detail to them. So that's a method that we could use there. If we use the aperture method, well, what does the aperture method do? Well, the aperture method in this particular case kind of focus on that. It's done mainly vertical lines, and it's giving me some irregular selections to that ridge region, meaning I could probably grab this information and use it to help me erode just different sections of the surface. So if I wanted to irregularly erode or alter the different regions, this is giving me that possibility. If we look at the surf text method, the surf text is coming in here and it's trying to give me ridges. Oops. So I've got the little ridges in there. And if we try and isolate that, when get all the flat regions, then we can adjust values. Again, trying to fix that mid value. But we got top ridges, bottom ridges, which we could then isolate individually using other tools. So we have that. And then we have our Sharpen method. And the Sharpen method is again doing something similar to what we had with the blur, where it's isolating that big back area, but other areas are sort of less involved. Although we can expand that, just as we could with the others. And that's that. So once again, as I said, you want to look at what kind of benefits you can get from each different method. They will give you different things, and you can use them in different ways. Be creative, explore, experiment, and there's yet more things going on here. So again, the basic principle of just doing something to a surface and then doing a difference to see what it gives you, that's part of that experimentation. Do something random. Go ahead and do a stratify to a surface and do a difference. What does that do? What does that look like? You get some interesting results, I promise you. It's actually quite cool. Just go and take any kind of primitive surface, a mountain or Voronoi or Perlin or whatever, stratify it with a pretty strong level, and then do a difference at 100%, and you will see some interesting shapes come off of that. The various different methods of doing things in here all change the surfaces in different ways, and that can give you lots of cool opportunities. So to finalize this, we will show you how this relates to that brick wall. So if I come in here, I've got a lovely Voronoi. Somebody in the Facebook group just posted something that has kind of an idea going in the right direction. So ultimately, I wanted to have the edges, and by doing a blur, it's going to do interior and exterior edges, which it's going to give me greater thickness because this is straight up and down. So if I grab this edge and this edge and then combine them together, because we can see the difference here, then what I'm going to end up with is a nice thick line. And the amount of blur will determine thickness. If we do a combine on that as a difference, you can see what it's done. It's isolated all the little lines in between them, and then if we do a height, fall off 0 and set a really extreme range, then we get nice thick lines all over. Of course, I'm going in and I'm taking the terrain and reducing its height. So I get variable height here still, but not as extreme. And then I subtract that. And then we end up with something like this. So I get the variable height that I want, and I get the seams in between them that I want as my starting point for what I'm going to be doing further with the rest of the bricks. Now, one other detail, the final hint to give you what you can play with to try and figure out how to make those bricks, is that you can come in here one direction there. If we come over here and change that, it goes in the other direction. So if you think about that information, as well as how we're selecting the lines here, might get you a little bit closer to the bricks. So that's hint number 2. And the final hint will come in the form of yet another tutorial. So I'll see you then.